Solve problem on control charts for the variables by using first control charts for the sample means x bar chart. Second, control charts for the sample ranges R chart.
Let us understand some important formulae related to control chart for variables. There are two types of charts, X bar chart and R chart. We will consider sample size is equal to n. That means in each sample there are n number of readings and which we say as x1, x2 up to xn. Then how to calculate its average? So its average is x bar and which is equal to x1 plus x2 plus up to xn divided by n. Now there is the first sample, second sample, third sample up to k number of samples. Number of samples if we consider which is equal to k, then how to write the average for each sample? So we can write here x1 bar, x2 bar up to xk bar. Now for the average of each samples, again we have to calculate average sample means. So how to calculate this? So notation is x double bar and x double bar is equal to x1 bar plus x2 bar plus up to xk bar divided by k. Now to draw this x bar chart, there are three parameters required. First one, control or center line which is known as CL. Second one, upper control limit that is UCL. And third one, lower control limit that is LCL. So these are the three important parameters to draw the X bar chart. So for that we will use the two notations. First one, sigma, that is the standard deviation and that is mentioned in the question. Then Z, that is standard normal deviation. So this value of Z is mentioned in the question in such a way that there is 2 sigma or 3 sigma. So suppose there is 2 sigma, that word is mentioned in the question, then value of Z we have to consider 2. Suppose there is 3 sigma that is mentioned in the question, then value of Z, that is standard normal deviation, we have to consider as a 3. Now we will move how to calculate these three important parameters. So centered line, that is CL, and we will take this value as x double bar. So x double bar can be calculated by using this formula. Then the second one, upper control limit, that is UCL, which is equal to x double bar plus Z sigma by root n. So this sigma is also mentioned in the question, that is the standard deviation, and this root n, that is n is the number of samples, that is the sample size. In each sample number of readings or number of units are there and that is the value of n that we have to consider here. Now for lower control limit, LCL is equal to x double bar minus Z into sigma by root n. So if we observe, these three parameters are required to draw the X bar chart. So with the help of all these three we can easily draw this X bar chart. Now we will move to the next point, that is the R chart. So for this R, that is the range. So how to calculate this range? So for each sample, suppose there are n number of readings, that is x1, x2 up to xn, then out of these readings we have to find out the maximum value and minimum value. And the difference in between this maximum and minimum is known as range. So it is easy for us to calculate range for each sample. So for sample 1, range is R1. For sample 2, range is R2. And for the kth sample, because number of samples k, then this that is the range is known as Rk. So R is equal to x maximum minus x minimum, and R bar is equal to, that is the average, that is equal to R1 plus R2 plus up to Rk divided by k. Now again for this R chart also, three parameters parameters are important. First one, center line CL, upper control limit UCL, lower control limit LCL. Now there are the different values that are mentioned in the chart, and that chart is provided in the examination. So which are those values? So now this centered line, that is CL, that is equal to R bar, and R bar we can calculate by using this formula. Now for the upper control limit UCL, D4 R bar. Now this value of D4 that we get from the chart provided in the examination, and that will depend upon the value of n. So we have to take for this sample size n, and for this particular sample size n we have to take the value of D4. Then again, which is equal to, we can use the second formula, x double bar plus z R bar by D2 under root n. So here x double bar, that we can calculate, z that is mentioned in the question, standard normal deviation, R bar that we can calculate, and what is this small d2. So this d2 also mentioned in that chart provided, and that is also depend on the sample size n. And here under root of n, that is the sample size. Then the next formula is x double bar plus a2 R bar. So this value of a2 is also mentioned in this control chart. Then the lower control limit. So for this lower control limit, LCL is equal to D3 R bar. D3 depends on the sample size n, and that is the chart provided in the exam, which is equal to, so second formula, x double bar minus z R bar by D2 under root of n. And the third formula, x double bar minus a2 R bar. So here value of a2 and d2 we can find out from the sample size n. And we can also say that sigma is equal to R bar by d2. So we can calculate the sigma, because here instead of R bar by d2 we can use the formula, that is sigma by root n. So here all these formulas you have to note down in your notebook, and which is important to solve the problems.
Given question. A quality inspector took 5 samples, each with 4 observations of the length of time for a glue to dry. The analyst computed the mean of each sample and then computed the grand mean. All values are in minutes. Use this information to obtain 3 sigma control limits for mean of future times. It is known from previous experience that the standard deviation of the process is 0.02 minute.
Let us understand the given data mentioned in the question. Number of samples k is equal to 5. Then the number of observations n is equal to 4. 3 sigma control limits, that means z is equal to 3, and standard deviation sigma is equal to 0.02 minute. Now in question this table is mentioned, that is for each sample there are 4 observations. So from this we can calculate the value of x bar. So what is the formula to calculate this x bar? So we have seen that x bar is equal to x1 plus x2 plus up to xn divided by n. Now here n is equal to 4. So how I can write this? That is x1 plus x2 plus x3 plus x4 divided by 4. So this is the value of x bar for each sample. So that is for the sample number 1 we have to take 12.11 plus 12.10 plus 12.11 plus 12.10 divided by 4, and this average is 12.10. Now in the same way for the second sample, if we calculate this 12.15 plus 12.12 plus 12.10 plus 12.11 divided by 4, then it is 12.12. Then for the third it is 12.11. Then for the fourth it is 12.10, and for the last it is 12.12. 12. So this is the value of x bar. Now we will move to draw the x bar chart. So how to draw this? So for the horizontal line we have to show the sample number. So there are total 5 number of samples. So we will start from 0, 1, 2, 3, 4, 5. So at equal distance we have to plot this number. So you can take here 1 centimeter, 2 centimeter as per the space available. And on vertical line we have to plot this value of x bar. Now if we observe here, this range is from 12.10, 12.11 and then 12.12. So approximately we have to start from this 12 number, or we can say 12.05, or we can say it's 12.08. So I have started here from this 12.08. So keep here some sufficient space after 0, and we have to start it from 12.08, 12.09, 12.10, 12.11, 12.12, 12.13 and 12.14. So for these numbers, to plot these numbers, we have to consider some sufficient space. That is, we will take the equal distance, that is 1 centimeter. You can also take 2 centimeter as per the space available. So important question is that we have to keep this equal distance. We have to plot these numbers at equal distance apart. Now how to plot these numbers? So for the first sample, so if I observe, here is the vertical line for the first sample. So this is the rough line I will draw here, and along this vertical line we have to plot 12.10. So 12.10 is here. So I will show here one point with the help of red marker. Then the next, for the second sample, it is 12.12. So here is the second sample number. So along this vertical line we have to plot here 12.12. So we will take here the horizontal line and vertical line. So here is this point. Then for the third point, it is 12.11. So for this 12.11, along this horizontal line and vertical line, we have to plot here the third point, that is for 12.11. Then for the fourth sample, 12.10. So for the fourth sample again, it is 12.10. Then for the fifth sample, it is 12.12. So here is the fifth sample. Then here is the 12.12. So we have to show these points. Now we will decide center line, upper control limit and lower control limit by using important formulas. We will calculate the value for x double bar, that is for the centered line CL, and formula is x1 bar plus x2 bar plus x3 bar plus x4 bar plus x5 bar divided by 5, because there are total number of samples, that is equal to 5. So we have to consider these values, that is 12.10 plus 12.12 plus 12.11 plus 12.10 plus 12.12 divided by 5, and which is equal to 12.11. So this is the centered line. So we will draw here one center line at the point 12.11. So here is the 12.11. So we will consider here one horizontal line, and this point lies on this 12.11 and this is known as CL. Now we will calculate the next upper control limit, which is equal to x double bar plus z sigma by under root of n. So here x double bar, that is 12.11 plus z, value of z is 3, sigma, that is the standard deviation 0.02 under root of n. So there are value of n, that is 4, that is under root of 4. So when we calculate this, we will get 12.14. So again I will draw here one horizontal line for 12.14. And this is the upper control limit. So we have to mention here upper control limit. Now for this lower control limit, x double bar minus z sigma by root n. So if we calculate by putting the value, then it is 12.08. So I will draw here one horizontal line for 12.08. So this is the lower control limit. So we have to mention all these. Now we have to write the answer by observation. Now if we observe here, all these readings, that is all the points lies under this lower control limit and upper control limit. That means we can say that this process is under control. So no any point cross the boundary for this upper control limit and lower control limit.
Given question, a company manufactures screws to a nominal diameter 0.500 plus minus 0.030 centimeter. 5 samples were taken randomly from the manufactured lot and 3 measurements were taken on each sample at different lengths. The readings are shown in the table. Calculate the control limits on X bar and R charts and draw the charts. This question was asked Dayalbagh Education Institute, Agra, BBM, May 2010.
This is the given table. There are 5 number of samples and for each sample there are 3 observations. So first step is to calculate X bar for each sample. So how to calculate this? So we have to add all these numbers for the 3 observations, that is 0.488 plus 0.489 plus 0.505 divided by 3. Answer is 0.494. In the same way, we have to calculate the value of X bar for these other samples, that is second, third, fourth and fifth, and here are the values. Now we will calculate X double bar. So how to calculate this? So value of X bar for the first sample, we will consider this as a X1 bar, this is X2 bar, X3 bar, X4 bar and X5 bar. So X double bar is equal to X1 bar plus X2 bar plus X3 bar plus X4 bar plus X5 bar divided by 5. So when we calculate this, when we add all these values and divided by 5, then the answer is 0.499. Now in this question, we have to calculate the value of R also. So how to calculate this range R? That is, for each number of sample, we have to select the maximum value of X and minimum value of X. So for sample 1, maximum value of X, that is the maximum value of this observation is 0.505 and minimum value is 0.488. So when we take the difference, then we will get the answer 0.070. Now in the same way, we have to calculate the other values, that is range for sample 1 is known as R1, range for sample 2 is known as R2, R3, R4 and R5. So here are the values. Now from these values we can calculate the value of R bar, that is equal to R1 plus R2 plus R3 plus R4 plus R5 divided by 5. So when we add all these values and divided by 5, then the answer is 0.080. Now how to plot the X bar chart? So on horizontal line, we have to plot the number of samples. There are total 5 number of samples. So we have to take the equal distance. So you can take 1 centimeter, 2 centimeter as per the space available, and we will plot here. So we will start from 0, 1, 2, 3, 4, 5. On this horizontal line there is sample number, and on vertical line we have to plot the values of X bar. Now if we observe here, minimum value is 0.494 and maximum value 0.505. So nearby this we have to start from the plotting the value. So I will start from 0.480. So if I take, that is the first value as 0.480, then in between this 0.480 and 0.490 I will take this 10 centimeter, because these are the values, that is 494, 496. So for the understanding purpose I have taken here the 10 centimeter distance. You can take 5 centimeter if space is not available. So here in between 0.480 I will take here 0.490, but in between that middle point, that is after 5 centimeter, I will take here 0.485. So again here after 0.490, after 5 centimeter, I will take here, or I will show here one point for 0.495, then 0.500, 0.505, and then 0.510. So these are the points that we have to plot. Now how to make here the points? So for the sample number 1, so here is the vertical line for sample number 1. Value is 0.494. So here is 490 and here is 495. So here distance in between them, that is in between 490 and 495, is 5 centimeter. So if I take 1 centimeter earlier than this 495, then here is 0.494. So I will take here the point of intersection. So if I draw here rough line, that is from 0, and this is the vertical line, then here is the point of intersection. So this point of intersection is our first observation. So I will remove these rough lines. Then we will move next, that is for second sample, it is 0.496. So here is 0.495. So after that 1 centimeter, here is 0.496. So again I will take here one horizontal, rough horizontal line, and from sample number 2, here is the vertical line. So here is the point of intersection. So this is our second reading. Then 0.500. So this is for the third. So here is 0.500. So if I take here the vertical line and here is the horizontal line, then this is the point of intersection. So this is the reading for the third sample, that is 0.500. Then next one 0.505. So for the fourth sample, it is 0.505. So that is also available. So on this vertical line, and here is the horizontal line. So here is the point of intersection. So I will show here this point. Then 0.499. So if we observe before this 0.500, once if I take 1 centimeter distance, then here is the value of 0.499. So this is for the fifth sample. So if I draw here one horizontal line and here is vertical line, then here is the point of intersection. So this is our fifth reading. Now we will prepare our chart. On horizontal line we have to plot the sample number, that is 1, 2, 3, 4, 5. So we have to plot these numbers at equal distance apart. So we have to start from 0. So 0 to 1, suppose there is 2 centimeter distance, then in between 1 to 2 there is same distance, that is 2 centimeter. Now how to plot the numbers on vertical line? So for that we have to refer the values of R1, R2, R3, R4 and R5. So if we observe here, minimum value 0.005 and maximum value 0.028. So I will take here, or I will start here from this 0, then there is 5 centimeter distance and I will take 0.005. Again there is 5 centimeter distance, then 0.010, then 0.015, 0.020, then 0.025. So in this way we have to plot the values on the vertical line. Now we will start to plot the values. So first one, for R1, that is the for sample number 1, value is 0.017. So for that I will take here, after 0.015 there is 2 centimeter distance and then this value will be 0.017. So I will take here the 2 centimeter distance, I will plot here 0.017. And for the sample number 1, I will take here this vertical line and here is the point of intersection. So this is our first reading. Then the second point R2, it is 0.005. So here is 0.005. So if I take here this vertical line and this horizontal line. Here is the point of intersection. Then for R3 it is 0.028. So it is 3 centimeter after 0.025. So I will take here 3 centimeter distance. So point is here. So I will take 0.028 and here is the third sample. So I will take here the vertical line and here is the horizontal line. So this is the point of intersection. So this is our third reading. Then next one 0.022. So it is 2 centimeter after 0.020. Now if we observe, we can say 0.020. Then after 1 centimeter 0.021, 22, 23, 24 and 25. So in between 20 and 25, 5 centimeter distance. So I will take here 2 centimeter distance and I will mark here 0.022. Then this is our sample number 4. So if I take this horizontal line and here is the vertical line, then here is the point of intersection. So this is our fourth reading. Then for the fifth it is 0.018. Now if we observe, here is 0.015. So for 18 I have to take 1 centimeter after this 0.017. So I will mark here one point and this will be 0.018. And if I take here one horizontal line and vertical line, then here is the point of intersection. So this is our fifth reading. Now we will calculate the control limit values for the X bar chart as well as R chart. Now there are 3 number of observations. So value of n, that is equal to 3. Now how to calculate this value for the center line? So CL is equal to X double bar and this value we have already calculated 0.499. So I have to show here. Now if we observe, here is the point, that is 1 centimeter below this 0.500, there is 0.499. So from this I have to take here one horizontal line. So this is the value for CL, that is the center line. Then upper control limit. So for this upper control limit, formula is X double bar plus A2 R bar. So this value of A2 we have to find out from this sample size. So sample size n is equal to 3. So if we observe this chart for sample size 3, value of A2 is 1.02. So we will take here 0.499 plus 1.02 into 0.018 because R bar is 0.018. So when we calculate this, then we will get the answer 0.5174. So we have to draw here one line. Now if we observe, here is 0.510, that is 510. Then after this 7 centimeter, because of limited space available, I will draw here one line, that is for the 0.5174. Because of the limited space, but we have to take here the 7 centimeter after this 510. So I will take slightly upward and here is this upper control limit, that is UCL. Now we will calculate lower control limit and formula is X double bar minus A2 R bar. So this value of A2, that is 1.02, that we have to take, and if we calculate, then we will get the answer 0.4807. So we will take in between 0.480 to 0.481. That is because it is after 0 there is 7. So it is nearby to 0.481. So I will take here one approximate line, and that is for this lower control limit. And the value for this point is 0.4807. Now we will move to the next chart, that is the R chart. So for R chart also we have to decide these values. So how to decide the value for the centered line? So centered line is equal to R bar and that is 0.018. So how to plot the 0.018? So here is the 0.018. So we will consider here one line. So this is the center line. Then upper control limit. Now if we observe for this upper control limit, again we have to refer the sample size. So sample size n is equal to 3. And for this upper control limit, we will refer the value for the D4. So if we observe this chart, then value of D4 is 2.57. So what is the answer? 2.57 into 0.018, which is equal to 0.0463. Now if we observe, here is our last value 0.028. After that it is 0.030 and then there is 0.0463. So because of limited space available, this line is much higher than this our largest point. So I will consider here the approximate line because of limited space, and this is the upper control limit. Then we will move to calculate lower control limit. So for lower control limit, formula is D3 R bar. So again for the sample size n is equal to 3, what is the value of D3? So if we observe this chart, then value of D3 is 0. So 0 into R bar, that is equal to 0. So where is the lower control limit? So for this 0, I will draw here the same line, and on this line I will plot here lower control limit, that is LCL. Now it's time for the conclusion. Now if we observe all the readings for this X bar chart, so here is lower control limit, here is upper control limit, and all these points are under control because it is in between lower control limit and upper control limit. So no any point crosses the boundary of these two limits. So we can say that the process is under control from this X bar chart. Now we will refer the next chart, that is R chart. So for this also, if we observe, here is upper control limit and this is the lower control limit, and all the points are in between these two limits, that is no any point crosses the boundary for this upper control limit and lower control limit. So we can say that from this X bar chart and R chart, process is under control.